Hello, and welcome to Session 5, Introduction to 3D Printing. In this session, we will learn what 3D printing is and how it can be beneficial over traditional manufacturing methods. We will discuss different types of 3D printing processes, and finally, we will discuss the presence of 3D printing in the healthcare industry. So what exactly is 3D printing? 3D printing is an additive manufacturing process that creates three-dimensional objects from a digital file. The terms 3D printing and additive manufacturing are used interchangeably. Some other terms for this process include rapid prototyping, layer manufacturing, additive fabrication, and solid freeform fabrication. In the past videos, you learned about different methods of subtractive and formative manufacturing. Subtractive manufacturing is any process that involves the removal of material to form a final shape. Some examples include CNC machining, laser cutting, and drilling. Formative manufacturing is any process that deforms the material into its final shape. In this process, material is neither removed nor added. Some examples include stamping, die casting, and injection molding. Additive manufacturing is any process that involves adding layers of material on top of each other to form the final shape. So how does 3D printing work? Well, there are actually 7 different additive manufacturing types. Fused deposition modeling, or FDM, is the most common and well-known process. It is especially popular among 3D printing hobbyists. Stereolithography, or SLA, is another very common method used in industry as well as by hobbyists. The other types of 3D printing include powder bed fusion, material jetting, binder jetting, directed energy deposition, and sheet lamination. We will talk about some of these processes in depth in the next video, but for now we will focus on the FDM process. The FDM process was created by Scott Crump in 1989. He used a hot glue gun to prototype a toy for his daughter. Hot glue guns intake a solid stick of glue, heat it, and dispense hot liquid glue through a nozzle. The glue solidifies as it cools. You can imagine layering lines of hot glue on top of each other over and over until a three-dimensional object is formed. FDM uses the same process to dispense thermoplastics along the X, Y, and Z axes. Now let's take a closer look at this process. First, the heated material is dispensed through a nozzle along a platform in the X and Y directions. The shape is filled in, then either the platform drops down or the nozzle is raised up a bit along the Z-axis. The nozzle will dispense a second layer of material on top of the first layer. This process is repeated over and over until the final three-dimensional shape has formed. 3D printing technology has been around for some time now. In 1984, Chuck Hull, the founder of 3D Systems, patented the stereolithography (SLA) printing process. Then, in 1989, Scott Crump, the founder of Stratasys Limited, patented the FDM process. In the next 20 years, the rest of the 3D printing processes were developed. But then in 2009, the FDM technology patent expired, resulting in many small, independent companies creating and distributing their own FDM printers. This allowed for much more accessibility to the world of rapid prototyping. In 2012, desktop SLA systems became available to purchase. Today, small FDM and SLA printers for hobbyist and professional use can be purchased at pretty low costs. So far, we have learned that additive manufacturing is the creation of 3D objects from a digital file. But going from a digital file to a finished product takes several steps. All 7 types of 3D printing follow the same general process flow. First, a 3D model of your prototype must be created in a 3D modeling software, like Fusion 360 or SolidWorks. The 3D model is saved as an STL file, then uploaded into a slicing software. Slicing software takes the model and turns it into a code that a 3D printer will understand. In the slicing software, you will decide the print orientation and also generate supports. Pictured here is a model of a tree in 3 different orientations. In each orientation, you will notice some parts of the model are highlighted in red. The red indicates where supports must be generated in order to achieve a successful print. Supports are just extra material that provide structure to overhanging parts of your model. Here, the generated supports are shown in light blue. Next, the slicing software will slice the model into a stack of flat layers, essentially creating a path along the X, Y, and Z axes that the printer will follow. Now that the machine knows exactly how it will print the model, we need to ensure that the machine is set up to meet our needs. This includes feeding our material into the machine, changing the temperature of the printer's nozzle and print bed, and many other machine-specific operations. Finally, we can begin printing. The printer will build the model along with the model supports layer by layer. Now we have a fabricated part. This part will typically require some sort of post-processing, including the removal of the support structure, sanding for a smooth finish, painting, and even sometimes heat treatment. Each printing process comes with its own required post-processing techniques, but we will talk about some of those in the next video. Now, we finally have our final part. Now let's talk about the advantages of 3D printing over traditional manufacturing methods. 3D printing, along with 3D modeling software, allows for freedom of design. We are now able to create shapes that would be impossible to achieve with other methods. We can create far more complex geometries without additional time, cost, or labor. 3D printing also allows for mass customization or personalization. You can simultaneously print multiple parts, each one customized to meet a different individual's needs. The option to print on demand allows us to keep low inventory, which greatly reduces startup costs. Additionally, many 3D printing machines are available to purchase for relatively low costs. Some 3D printers are quite expensive, but when you factor in the cost of material and labor, 3D printing is still often less expensive than traditional manufacturing methods for low-volume production. So what are the limitations of 3D printing? Well, due to the layer-by-layer method of building, 3D printed parts are porous and have gaps between their layers. Sometimes these gaps are visible to the naked eye, and sometimes they are just on a microscopic level. This could be a problem depending on the application. Dimensional accuracy is another major limitation of 3D printing. In applications where any little deviation from the intended dimensions cannot be tolerated, some forms of 3D printing are really not the best method of manufacturing. Post-processing is the biggest challenge of 3D printing. Sometimes post-processing might be fairly easy, like breaking off supports or sanding down a part. But sometimes it includes methods that are time-consuming, difficult, and labor-intensive. While working with thermoplastics, the material expands as it's melted and shrinks as it cools. There are temperature differences between the print bed and each layer of material. Sometimes this causes warping and defects. 3D printers come in different sizes, some even big enough to print furniture, cars, or houses. But you are limited to the build volume of your specific printer. So if your prototype exceeds the printer volume, you must break up your model into smaller parts and assemble them afterwards. Some common applications for 3D printed parts include prototyping. In previous videos, we learned that 3D printing allows us to quickly move through the iterative design process. 3D printing is also great for mold making. You can directly print a female mold for casting, or you can print a male pattern and create a mold around that out of other material, like silicone. 3D printed architectural, educational, and medical models are another frequent application of 3D printing. Legacy or replacement parts that might be expensive or might not be in production anymore can be printed at low costs. 3D printed medical devices are also very common. We will be discussing more about 3D printing in the healthcare industry in a future video. So when should we use additive manufacturing and when should we use traditional manufacturing? Well, additive manufacturing is a great choice for low volume production, on-demand production or prototyping, when customization is required for each part, if you want to achieve complex shapes, and also if excessive materials would be wasted using traditional manufacturing. Traditional manufacturing methods are ideal for high volume production of identical parts that will undergo high or fluctuating loads, parts with strict tolerances that must be incredibly dimensionally accurate, when using materials that are not available as 3D printing materials, and when constructing very simple shapes.